In this video, we're going to look at the relationship between the pressure of the gas and the volume that it occupies. And this relationship is known as Boyle's Law. So let's just recall that the pressure of a gas is determined by the kinetic motion of its component particles. So each collision of a particle with the inner surface of the container exerts a force on that container's inner surface. And so the collective number of collisions, as well as the strength of those collisions, form the overall gas pressure. So when you're thinking about the pressure of gases, you can relate that to the collisions with the wall of the container. So an increased pressure means increased collisions. So let's look at the relationship between pressure and volume. And we're always going to be considering a closed system, so one that has a constant amount of moles of a substance and is not open to the atmosphere. So if the volume of a container that contains a gas is decreased, what will happen to the pressure if all other conditions, for example, temperature, remain constant? So we've taken the container and made it smaller. Well, if we do that, the pressure is going to increase because the gas molecules in the container have been forced closer together. So they're going to have a shorter distance to travel before they strike the container walls. So they're going to hit the walls more often, which means increased pressure. And that's shown in this diagram where the volume has been decreased. And so as you can see, the molecules are hitting the walls a lot more often, so the pressure has increased. And similarly, if you think about it in the other way, if the volume of the container is increased, what will happen to the pressure? Well, in this case, the pressure will decrease because the gas molecules are now further apart. They have longer distances to travel before they can strike the container walls, so they're going to hit the walls less often. So when volume decreases, pressure increases, and vice versa. When volume increases, pressure decreases. So they have an inverse relationship. And this relationship is known as Boyle's Law. So in words, Boyle's Law states that the volume of a given amount of gas at a constant temperature varies inversely with the applied pressure. And this can also be described mathematically with this equation. So pressure initial times volume initial is equal to the final pressure times the final volume. So we can use this equation to solve problems involving the changes in pressure and volume of a gas in a closed system. So if we look at an example problem, a sample of helium gas is collected at room temperature in a 4.50 liter balloon at standard atmospheric pressure. The balloon is then submerged in a tub of water, also at room temperature, such that the external pressure is increased to 110.2 kilopascals. What will the final volume of the balloon become? So we can start this by listing our givens. So our initial pressure, it said, was standard atmospheric pressure, which is 101.3 kilopascals. The initial volume, 4.50 liters. The pressure was then increased to give a final pressure of 110.2 kilopascals. And the question is asking us for the final volume. So we take the equation, PIVI is equal to PFVF, and we sub in the values that we've been given. So they're all in their appropriate locations. So then we're going to solve for VF. So the first thing we're going to have to do is divide by the 110.2 kilopascals. So that cancels that out on the one side with the VF. It also cancels out the kilopascals. So the math that you need to do is 101.3 times 4.50 divided by 110.2. And when you do that, you get a final volume of 4.14 liters. And you can do a check to see if the math is most likely correct because you see that the pressure had increased. And so you check, did the volume decrease? Yes, it did. It went from 4.5 to 4.14. So chances are that you did the math correctly. So just a note about units when you're using Boyle's Law's equation. It doesn't matter what the units are for pressure or for volume, as long as the unit for the initial pressure is the same as that for final pressure, and the unit for the initial volume is the same as that for the final volume.